Ah, that familiar melody really takes us back, doesn't it? I can still remember running around the observatory as a kid, guiding Mario to every corner of the cosmos, all the way back in 2007. Reflecting on Super Mario Galaxy, there's something magical about this game that stirs a deep sense of nostalgia in me. I vividly recall those afternoons, rushing home from school with a heart full of anticipation. It wasn't just about playing a game, it was about returning to my beloved virtual home and shooting off to whatever new galaxy I could. I think that connection, that joy of discovery, is what makes Super Mario Galaxy so unforgettable for me and so many others. Given how much this game has meant to me, it sparked a curious thought. Could an artificial intelligence, with its intricate algorithms and growing capabilities, also find joy in this masterpiece of a game? And hey, let's not forget, when AI reaches its full potential and, casually takes over the world, maybe it will remember the good old days when I let it play Super Mario Galaxy on a school night. Maybe it could be just what I need to stay on AI's good side. So with this thought in mind, it was time to set our AI up with its very own galaxy to conquer. And what better choice than the sweet, sweet galaxy, the land of precarious platforms and confectionery chaos. I chose this galaxy specifically because I wanted to start our AI off with something fairly simple. But if you want to see more Super Mario Galaxy, be sure to let me know, and I'm definitely down to send our Silicon sidekick on a journey to beat up Bowser. Anyway, it's undoubtedly going to take a bit of time for our AI to learn this sugary nightmare of a galaxy, so I think it's about time we let it begin, whilst I explain roughly how it works. This AI uses a highly sophisticated network architecture called the Impala network, which takes only the screen from the game and is able to then output an action which it thinks is best. To understand the Impala network, we need to go on a bit of a journey though. The Impala network has a total of 4 parts, all which work together to make up the total neural network, and I'm going to break them down one by one. Firstly, we have the convolutional layer, which is a bit like the AI's eyes. Just like our eyes can spot different shapes, this layer helps the AI see and understand various elements in the game, from random patterns on the ground to dangerous electrified fences. It's a bit like having a superpower for pattern recognition, which is why it's so popular in AI systems that work with images. Secondly, we have the max pooling operator. After the convolutional layer does its job of spotting things, the max pooling operator steps in. It's like looking at a busy painting and only picking out the most important parts to focus on, ignoring the rest. This helps the AI not get overwhelmed by too much information, which isn't relevant. Up next we have the residual convolutional layer. This part is quite similar to the first convolutional layer, but with a twist. It's like a smart assistant that can do what the convolutional layer does, but also let information pass through unchanged. This is especially helpful in larger networks, as it ensures some of the original, unaltered information can travel further along the system, aiding in better decision making. Lastly, we have the fully connected layer, where all the magic happens. After all the observing and filtering, the fully connected layer acts like the AI's decision maker. It takes all the insights gathered by the previous layers and turns them into actual actions that the AI can take in the game. It's like the brain's command center, making the final calls on what is actually to be done. So there you have it, the Impala network, the powerhouse behind our AI's brain. With this advanced setup, our AI is fully equipped to navigate the twists and turns of the sweet, sweet galaxy. While it might not master everything overnight, give it a day or two and we'll see just how good this AI can get. A crucial step in prepping our AI for the gaming challenge was to define its toolkit. Essentially, what moves it could take in the game. Just like teaching a player how to use a controller, I had to teach the AI how to control Mario using a virtual Wii remote and nunchuck. After some thought, I settled on 6 basic actions for the AI. Doing nothing, moving in each of the 4 cardinal directions, and jumping. I decided to keep it straightforward for now, leaving out more complex moves like long jumps and backflips. But don't worry, those flashy moves are definitely on the agenda for future videos. The final puzzle piece in training our AI was figuring out how to effectively guide its actions through the use of rewards. Essentially, when to give it a virtual pat on the back and when to say, better luck next time, try again. My initial plan was to find a single data point in the Wii's memory that showed Mario's progress through the level. This idea was simple. Every time this progress value went up, the AI would get a reward. Turns out, it wasn't that straightforward though. I couldn't find one magic number that tracked progress. But by piecing together several different data points, I managed to create a good enough system. Beyond just tracking how far Mario got in the level, I also needed to monitor a few other key details. This included Mario's health to discover that AI from running into those pesky electric fences, and the number of lives left, so that AI would learn that losing a life isn't ideal. And of course, reaching the star at the end of the level deserved a big reward. After all, that's the ultimate goal that we're going for. Anyway, as you can see, with all of this in place, the AI was able to absolutely obliterate the Sweet Sweet Galaxy, generally beating this level easier than I can. Here's the final graph of the AI's progress, showing the average reward that agent received throughout training. As you can see, it made good steady progress pretty consistently for the first 40 hours of training. After that, it pretty much stopped improving though, since it was already getting the maximum reward for finishing the level on basically every attempt. Even after 40 hours though, the AI did get faster, opting for more triple jumps and other ways to get the reward even quicker. But sadly, the graph doesn't really show this, since it only shows the total reward received per episode. Since this is the first time I've attempted to get an AI to play Super Mario Galaxy, I kept the task fairly simple just to see if things would actually work. But this AI really blew me away with how well it was able to do. With that in mind, if you want to see it, I'll definitely be looking to test the AI's skills out on some harder levels. I've particularly got my eye on the final level, known as the Fate of the Universe. Anyway, thank you all so much for watching as always, and I hope to see you again in the next one.